Okay, guys, we're going to do the check you understand on page 691. Some biologists are working with fruit flies that have specific genetic makeup for eye color and wing type. So they mate two fruit flies with various genes, and any offspring that has a capital R will have red eyes, and any offspring that has a capital C will have straight wings. So the small r, if it's dominant, will have white eyes, and the small c, if it's dominant, will have curly wings. Okay, so from our little Punnett square here, they predict a ratio of 9 red-eyed straight wings, 3 red-eyed curly wings, 3 white-eyed straight wings, and 1 white-eyed curly wing offspring. So this is what we would predict or expect. Okay, so to test their hypothesis of the distribution of offspring, the biologist made a random sample pair of fruit flies. There's 200 offspring. 99 have the red eye straight wings, 42 have the red eye curly wings, 49 have white eyes and straight wings, and 10 have the white eyes and curly wings. So does the data differ significantly from what the biologists have predicted? We're going to do a significance test at a 1% significant level. Okay, so again, kind of pre-written stuff. This is check your understanding on page 691. It is a chi-square goodness of fit. So what is our state? Our state is that the distribution of eye color and wing type is going to be exactly what the biologists predict. Okay, so I can write it out in words like this, or I can do, my proportion. So my proportion of red eyes, straight wings should be 9 out of 16 because that's 9 and the total is 16. Okay. The proportion of red eyes and curly wings should be 3 out of 16. What is that? White eyes and straight wings, 3 out of 16. And then white eyes, curly wings is the 1 out of 16. I don't have to put both. Okay, again, I'm going to put this in brackets. If I write that, that's fine. Okay? So if I said the distribution of eye color and wing type is what the biologist would predict for my ha is going to be that it's not going to be what I predict. So then I'm going to say the distribution of eye color and wing type is not what the biologist would have predicted. Now for my ha, if I had put, for my ho, if I'd put in proportions, for my ha, I would have to say at least 2 of those proportions are not correct. So either these 2 go together or these 2 go together. You don't have to put all 4, okay? And I tend to use the words. Words just make more sense to me, but I want you to be familiar with it again because you might see the proportions listed. Okay. Oh, our alpha, I believe it said 0.01. Yes, indeed. Okay. Let's do our plan. So again, our plan, indeed, it is a chi-square goodness of fit. So I'm going to abbreviate goodness of fit. Random, I do believe it said biologists made it a random sample of random sample of pairs of fruit flies. So stated, used a random pair of fruit flies. I can't say that very fast. Okay, independence, 10%. Let's see, how many fruit flies did they use? 200? I'm pretty sure there's more than 2,000 fruit flies. And we're going to say fruit flies are independent, relatively speaking. Okay. Now let's do our large or expected counts. Okay, so I did a little chart here. So I've got my red eyes, straight wings, red eyes, curly wings, white eyes, straight wings, white eyes, curly wings. So what did we observe? Let's see, we observed 99 red eyes and straight wings, 42 red and curly, 49 white and straight, and 10 white and curly. So that's what I observed. Okay. Now, I got to calculate what I expected. So what I'm going to do, this total should be 200, and I do believe it is. Okay, these are my 200 fruit flies. So if I kind of go back to my proportions, if I do 9/16 of 200, I'll get how many red-eyed, straight-winged fruit flies I should get. So I'm going to do 200 times 9/16 for the red straight. For the red curly, I'm going to do 200 times 3/16. Okay. I'm not going to calculate it again because it'll be the same number for white and straight. And then white and curly, I'll do 200 times 1/16. Okay. So what I would expect, throwing that in the calculator, I would expect 112 and a half RS's, red and straight, 37 and a half each of red and curly and white and straight, and then 12 and a half of white and curly. So I look at these, that looks close. These look a little off. I don't know. Are they close? I don't know. Whatever. We'll let statistics determine it. Okay. So again, this should total 200, and it does. Are my expected counts all greater than 5? Yes, indeed. Okay. So all expected counts are greater than or equal to 5. So conditions are met. Okay. And again, don't make that statement without showing this work. Okay. You gotta show those expected counts. All right, let's do the chi-square statistic. Okay, I'm going to move the book out of the way. Let's do the chi-square statistic. So again, I've got 4 categories. So I'm going to set up 4 little ratios here. Okay, and remember it's observed minus expected squared over expected. Observed, make sure you can see all those numbers. Observed minus expected squared over expected. Observed minus expected squared over expected, and then observed minus expected over expected. Okay. If I do all those individually in the calculator, okay, and it's a good check, I should get, let's see, 1.62, 0.54, 3.53, and 0.5. Add all those up, okay? So if I add all those up, my chi-square should equal 6.19, okay? Now this is where I go to the calculator, okay, to get my p-value. So I'm going to run the test. So if we recall, we have to put our observed and our expected in list 1 and list 2. So our observed or our actual is in list 1. And my expected is going to be in list 2. Okay, so now I'm going to go back and get my chi-square goodness of fit, which is right there. Yes, I have my observed in list 1. Yes, I have my expected in list 2. Oh, degree of freedom. Degree of freedom, again, is number of categories minus 1. So I have 1, 2, 3, 4. 1, 2, 3, 4 categories. So my degree of freedom is 3. Got it. Okay. And I'm going to calculate. So I can check all this. Okay. I'm not going to draw the curve. You don't need the curve. So I'm going to calculate. So, ooh, like my chi-square, got that. Whoops, can you see? Got the chi-square. My p-value, 0.1029, all right. Okay, and then I'm going to check each component of my chi-square statistic. So there's my 1.62, there's my 0.54, and again, I'm just scrolling with my little arrow right here. 3.53, and then 0.5. Okay, so I feel good, got it all right, I'm happy. Okay, so now we'll compare our p to our alpha as we usually do. Sorry, I've pre-written my conclusion. So 0.103 I'm going to say, because that's what I wrote in my conclusion. Okay, that is not true. Okay, so my p is not less than my alpha. So we know that we are going to have to fail to reject the hoe. So if I fail to reject the hoe, I do not have convincing evidence that the distribution of eye color and wing type is not what the biologist would have predicted. Okay, so let's look at that. So the p-value, 0.103, and again, I just rounded a little bit, is not less than alpha of 0.01, so we fail to reject the hoe. We do not have convincing evidence that the distribution of eye color and wing type is not what the biologist would have predicted. So, in other words, the distribution of these traits in the fruit flies is pretty much what the biologist would have predicted. Since I failed to reject the hoe, I do believe that they are all what the biologist thought would happen. And gotta love it. Okay. All right. Thanks. See you next time.